All right, so today let's do a deep dive into optimizing a high-end DC.
Okay.
We're going to be talking about the Holo Spring 3
Oh, cool.
and how one audiophile managed to kind of squeeze even more performance out of it.
Wow.
Are you ready to geek out a little bit?
Absolutely, yeah. The Spring 3 is a fantastic DC already.
Yeah.
Really well known for its transparent and detailed sound. But there's always that question, can you push it even further?
Exactly, and that's where Ian Canada comes in.
Okay.
He's this DIY audio enthusiast who meticulously documented his journey of tweaking the Spring 3.
Wow.
And his findings are really fascinating.
I can imagine.
We're talking external clocking power supply upgrades.
Oh, wow.
The whole 9 yards.
I'm intrigued.
So what I find really interesting is his focus on the digital signal itself.
Okay.
He's not modifying the DC's internal circuitry.
Right.
He's feeding it a superior signal from the get-go.
From the source.
Yeah. So let's start with Ian Canada's initial impressions.
Yep.
He really loved the Spring 3's signature R2R sound. Transparent, detailed to clean soundstage.
Yeah.
But he felt, compared to his reference Delta Sigma today,
Right.
the imaging wasn't as precise.
I see.
Instruments weren't locked in 3D space the way he wanted.
Interesting.
Oh, and he also notes that the Spring 3's output voltage is higher than standard.
Oh, okay.
It's 2.9 V RCA, 5.8 V XLR.
Hmm.
Something to keep in mind if you're pairing it with other equipment.
Yeah, that's a subtle detail, but it's important.
Yeah.
And that desire for pinpoint imaging is what really set him on this optimization journey.
Exactly. So his hypothesis was that the Spring 3's internal clock might be kind of the limiting factor.
Okay.
So he decides to bypass it entirely.
Wow.
And feed the DI with an external clock signal using I2SDSD over HDMI.
Interesting. So that's where his custom network streamer transport comes into play.
Yeah.
It acts as a dedicated clock source.
Right.
It's also called a DDC, and it's quite the setup.
Yeah, it is.
It's a FifoPi Q7II HDMI Pi Pro monitor Pi Pure Pi, all powered by a Raspberry Pi 4B.
Yeah, that's a mouthful.
It is.
But basically, he created this ultra-low jitter digital transport that feeds the Spring 3 with incredibly precise timing information.
Very cool.
So what kind of results did he see with this external clocking setup?
Or he reported a wider soundstage for sure.
Oh.
Instruments became more focused in their positions. It was definitely a step in the right direction.
Yeah.
But he still felt there was room for improvement.
Oh.
It wasn't quite matching the imaging precision of his reference, DAC.
So the hunt for better sound continued.
It did.
And this is where the power supply enters the picture.
Yes.
I'll admit, the connection between power and sound quality wasn't immediately obvious to me.
I can understand that. It's a bit of a rabbit hole.
Yeah.
But it makes a big difference.
Yeah.
Even tiny amounts of noise in the power supply can affect the delicate clock circuitry.
Right.
Introduce jitter and degrade the sound.
That makes sense.
Yeah.
So how did Ian Canada tackle this power supply challenge? Did he just swap out the stock power cable or something?
It's more involved than that.
Okay.
He went on this two-step upgrade process.
Okay.
First, he added a U-Conditioner Pi 3.3 to his setup.
What does that do exactly?
Think of it as a filter that removes noise from the power line.
Okay.
It yielded noticeable improvements already.
Wow.
But he didn't stop there.
He went even further down the rabbit hole.
Oh, yes. He replaced the battery power supply with a UcPure MkIII 3000F ultracapacitor power supply.
What?
And according to him, this was the biggest game changer.
Ultracapacitor power supply.
Yeah.
I'm not going to lie, that sounds a bit intimidatingly technical.
I can see that.
What are ultracapacitors?
Okay.
And why are they so special in the audio world?
They're energy storage devices like batteries.
Okay.
But they can charge and discharge incredibly quickly and smoothly. Imagine a perfectly smooth, uninterrupted flow of power.
Yeah.
With virtually no noise.
So it's like a super clean power source.
Yes. Specifically designed for sensitive audio equipment.
Exactly. And here's why Ian Canada and many audiophiles believe ultracapacitors are a step above active regulators, or LDOs, which are more commonly used in power supplies.
Okay, let's break that down, because I'm sure I'm not the only one who needs a bit of a primer on this.
Of course.
What are the downsides of those traditional power supply components?
Well, active regulators, while effective, rely on control loops and feedback mechanisms to maintain a stable voltage.
Okay.
This constant adjustment, while aiming for stability, inherently creates a certain level of noise.
Oh.
Imagine trying to keep a pencil perfectly balanced on your fingertip.
Okay.
You're always making these tiny adjustments.
Right. So even the best active regulators have this inherent noise floor because of their operating principle.
Precisely. And then you have LDOs, or low dropout regulators. While they're simpler than active regulators, they still introduce noise, particularly at higher frequencies. So what makes the UcPure ultracapacitor power supply different?
Okay.
How does it manage to be so quiet?
It's all about being passive.
Okay.
In its pure mode, the UcPure has no power input.
Wow.
It simply releases the stored energy from the ultracapacitor, which is incredibly clean and stable. There are no active components or control loops constantly adjusting and generating noise.
So it sounds almost too good to be true.
It does, doesn't it?
Like removing all the potential troublemakers from the equation.
That's a great way to put it.
Yeah.
And Ian Canada found that this ultra-clean power, combined with the external clocking, had a dramatic effect on the Spring 3's performance.
Okay, I'm hooked. Tell me, what did this ultimate combination sound like?
Right.
Did it finally achieve that pinpoint imaging he was after?
Hold on, I'm getting to the good part.
Okay.
But before we reveal the sonic results,
Yeah.
let's take a closer look at why ultracapacitors are so effective at noise reduction.
Okay.
We'll get into the nitty-gritty of how they work and why they're becoming the go-to choice for serious audiophiles.
Sounds like a deep dive within a deep dive.
It is.
I'm ready when you are.
So let's break down why these ultracapacitors are so effective at delivering that clean power.
Okay.
It's all about their unique construction and how they actually store energy.
All right, lay it on me. What's the secret sauce here?
So unlike batteries, which rely on chemical reactions to store and release energy, ultracapacitors actually store energy electrostatically.
Oh,
Think of it like static electricity, but on a much grander scale.
So no chemical reactions means no messy byproducts
Exactly.
that could introduce noise into the power.
Exactly. It's a purely physical process, which makes ultracapacitors incredibly stable and quiet.
Okay.
Plus, they can handle thousands, even millions of charge and discharge cycles without degrading like batteries. They're built for the long haul.
Sounds impressive. But I'm still trying to wrap my head around how this translates into better sound. What did Ian Canada actually hear when he switched to the UcPure ultracapacitor power supply?
Well, remember how he was initially looking for that precise 3D imaging?
Yeah.
He found it with the UcPure.
Oh, wow.
He described the soundstage as being fully open, deep and wide, with instruments sounding like they were emanating from precise points in space.
So he finally achieved that holographic imaging he was after.
He did. He even said that instruments now sound like they're in 3D space.
Wow.
Fully separated with a "you are there" feeling.
That's awesome.
Quite a compelling endorsement.
I bet. It really highlights how crucial a clean power supply is, especially for a high-end DAC like the Spring 3 that's capable of resolving such fine detail.
Absolutely. And it's not just about the ultracapacitors themselves.
Okay.
The UcPure's overall design plays a role, too.
Right.
It uses very short signal paths and high-quality components to minimize any potential for noise introduction.
So it's like a holistic approach to power supply purity, not just a single magic bullet.
Exactly. Now, remember how Ian Canada was initially using a battery power supply?
Yeah.
He actually found that the UcPure provided a similar level of blackness to the background.
Interesting.
But with a more dynamic and lively presentation.
Ah, so it's not just about dead silence.
Right.
It's about preserving the energy and life of the music while keeping the noise floor incredibly low.
That's a great way to put it.
Yeah.
And Ian Canada wasn't the only one impressed by the UcPure.
Oh, really?
In the comments section of his blog post, other audiophiles chimed in with their own experiences.
Okay, let's hear what they had to say.
Yeah.
I'm always curious to see how these DIY tweaks translate into real-world listening experiences.
One commenter, who also had a Spring 3, was so inspired by Ian Canada's setup that they decided to try it out themselves.
Nice.
They reported being blown away by the improvement in sound quality.
Really?
Particularly with classical and jazz music.
What kind of improvements did they notice?
They specifically mentioned that the soundstage became much deeper and wider, with instruments having more space to breathe. And they found that the music had a more natural flow and rhythm.
Yeah.
Like they were hearing the performance in a more realistic way.
Wow. It sounds like Ian Canada's tweaks really resonated with this listener.
It did. And another commenter who was using a different DAC,
Okay.
the PS Audio Perfect Wave MkIII, was also intrigued by Ian Canada's work.
Yeah.
They decided to implement a similar external clocking setup using a FifoPi Q7II HMePi Pro 2 and a PurePi 2.
So they took inspiration from Ian Canada's approach, but adapted it to their own system.
Yeah.
That's really cool. What were their impressions?
They were ecstatic. They said their digital setup now rivaled their vinyl rig.
Wow.
Which is high praise indeed.
Yes.
They even went as far as saying it surpassed vinyl in terms of soundstage depth and width.
That's amazing. It really shows how these optimization techniques can unlock hidden potential in audio systems, even those that are already considered high-end.
It's a testament to the fact that the digital audio source is just as important as the DSC itself.
Right.
But before we get too carried away with power supply upgrades, there's one more crucial element in Ian Canada's setup that we need to discuss.
Okay.
Clock exploration.
Ah, yes. We can't forget about the clocks.
Nope.
It's the heart of the digital audio signal after all.
That's right.
What kind of clock adventures did Ian Canada embark on?
Well, he dived deep into the world of phase noise.
Okay.
Which is essentially jitter or instability in the clock signal.
And as we've learned, jitter is the enemy of good sound.
It is.
It messes with the precise timing of the digital audio signal.
Yep.
Blurring the details and muddying the waters.
Exactly. And Ian Canada is very particular about phase noise.
Okay.
He emphasizes that measurements need to be compared at the same frequency to be meaningful.
So it's not just about looking for the lowest noise floor.
Right.
It's about the shape and characteristics of the noise across the entire frequency spectrum.
You got it. He also points out that the noise close to the desired frequency, what he calls close-in phase noise, is particularly crucial.
So it's like a sniper targeting a specific frequency range.
Yeah.
Where the noise is most detrimental to the audio signal.
That's a great analogy. Now, in his quest for the perfect clock, Ian Canada experimented with various types of crystal oscillators, which are the heart of most digital clocks.
Okay, so what kind of crystals did he try and were there any clear winners?
He found that SC-cut crystal oscillators generally perform better than AT-cut ones in terms of phase noise and subjective sound quality.
So it's all about finding the right crystal for the job.
It is.
Just like choosing the right tool for a specific task.
Precisely. And he specifically mentions UcPure clocks as being superior in his listening tests.
Oh, cool.
He even provides detailed phase noise measurements of various clocks.
Oh, wow.
Highlighting the nuances of their performance.
It sounds like he really went down the rabbit hole on this one.
He did.
But what did these superior clocks actually do for the sound? What did he hear?
Hold that thought, because that's where we'll pick up in the next segment. Get ready for some sonic revelations.
All right, so we've talked about external clocking, ultracapacitor power supplies, and even the nuances of phase noise. What I'm really curious about is how all of these upgrades working together actually impacted the sound.
Right.
Do they live up to the hype?
Let's just say Ian Canada was pretty enthusiastic about the results.
Okay.
He said that with the UcPure clock in place, the improvements he'd already heard with the external clocking and the UcPure power supply were magnified.
Magnified. That's a strong word.
Yeah.
What exactly did he hear?
Well, he described the music as having this almost holographic quality.
Oh, wow.
Instruments weren't just precisely placed.
Yeah.
They had a tangible presence with a sense of body and texture that he hadn't experienced before.
So it wasn't just about pinpoint imaging anymore. It was about capturing the soul of the instruments themselves.
Exactly. He also noted that the overall presentation became more effortless and natural, with a sense of ease and flow that was truly captivating.
Wow.
It's like the music was being released from its digital constraints and allowed to breathe freely.
That sounds like the holy grail of digital audio.
It does, doesn't it?
Did he mention any specific genres?
It did.
Where these improvements were most noticeable?
He specifically highlighted classical music,
where
the subtle nuances of timbre and dynamics were rendered with breathtaking realism. He also mentioned that vocals took on a new level of intimacy and expressiveness.
It seems like he really achieved a level of sonic bliss with this setup.
It seems like it.
It's inspiring to see how someone with a passion for audio can make such a significant impact on their listening experience through careful research and experimentation.
It really is. And it underscores the fact that even with a high-end D like the Spring 3, there's always room for improvement.
Right.
The digital audio source and the power supply are just as crucial as the DAC itself.
Now, before we wrap up this deep dive, I wanted to touch on something Ian Canada mentioned in his blog post.
Okay.
This concept of diminishing returns.
Ah, yes, a crucial point.
Yeah, he advises against getting too caught up in chasing those last few percentage points of improvement.
Right. It's not about endlessly tweaking and upgrading.
Exactly. So it's about finding that sweet spot where the technical pursuit of better sound aligns with the emotional impact of the music itself.
Exactly. It's about achieving that delicate balance between performance and musicality.
Well said. I think we've covered a lot of ground today.
We have.
We've explored external clocking, the magic of ultracapacitors, the intricacies of phase noise, and the importance of finding that sweet spot in audio optimization.
Yeah.
What are your final thoughts on Ian Canada's journey?
Sure.
And what it means for audiophiles like us?
I think it's a powerful reminder that there's always more to discover in the world of high-end audio. It's about being curious, experimenting, and ultimately finding what brings you the most joy in your listening experience.
And who knows, maybe Ian Canada's story will inspire some of our listeners to embark on their own audio adventures.
I hope so.
Well, on that note, we'll leave you to ponder the possibilities.
Sounds good.
Thanks for joining us on this deep dive into the world of high-fidelity audio.
Yeah, thanks for listening.
Until next time, keep those ears open and those systems humming.